Hello, class. Today we are going to talk about the segments of secants and tangents. So just to remember, a secant, what this is in a circle, this is a segment or a line that intersects the circle twice and it keeps going, okay? It's okay to have one endpoint on the circle right here. Here we've got point A is on the circle, but then notice it goes all the way through the circle to point C. Okay, so these are secants. Okay, now secant segments, if you have two secants that intersect outside of the circle, okay, what's going to happen is the lengths of the segments will be such that segment BC times the length of segment AC is equal to the length of DC times the length of segment EC. Okay, so let's put some numbers on this just so we can see this. So BC is 12 times AC. Well, AC is 48 plus 12 is equal to DC, which is 10. Why is my pen not writing? This is weird. 10 times EC, which is 10 plus 62. All right. So, let's see it. So that would be 12 times 60 equals 10 times 72. 12 times 60 is 720. 10 times 72, also 720. Okay? Now, easiest way to remember this, because there's lots of different things there, this is the outside times the whole thing. The 12 times the whole AC. The 10 times the entire EC. So it's outside times the whole thing for both segments is going to equal. Okay? All right, so that's if you have two secants intersecting. We have a secant and a tangent. To remind you what a tangent is a line or a segment that just touches the circle at one point. So it's tangent at point D. It just barely touches the circle at that one point. And the way this works, you have BC times AC is equal to DC squared. Okay, so again, with some numbers, BC is 4, AC is 4 plus 5, and this is equal to DC, which is 6 squared. So if you'll notice real quickly, again, BC, that's the stuff that's outside. AC is the whole thing. So you have outside times the whole thing equals DC squared. And if you'll notice, DC is what's outside and DC is also the whole thing. So it's still outside times whole thing. It's just that in the case of a tangent, the outside is the whole thing. So it's times itself. So we have 4 times 9 is equals 36. And yeah, 4 times 9 equals 36. All right, so let's do a couple of examples. We're going to find x. So here we have two secants, and remember what we want the outside times the whole thing. Times outside times the whole. Okay, so well, we'll do the first. Outside, we have 10 times the whole thing, which is 10 plus 20. On the other one, we have the outside, which is 12 times the whole thing, which is 12 plus x, whatever x is. Okay, so let's see. 10 plus 20 is 30, so I have 10 times 30 equals, and I'm just going to drop this down. You could distribute in, but in this case, it'll be easier just to drop this down and leave it as 12 times 12 plus x. All right, so 10 times 30, that's easy enough. That's 300 equals 12 times 12 plus x. And here's why I did not distribute in, because now I'm just going to distribute by this 12, or not distribute, I'm going to divide by this 12 here. And so this becomes 25 equals 12 plus x, subtract 12, and 13 equals x. So x is 13. And if it was asking for, say, IG, because you got to pay attention to this, IG is the whole thing. That is this right here. That is the 25. Okay? So make sure you do get that out and solve for whatever it is you're actually looking for. Okay? So again, it's the outside times the whole thing. Okay, one more example. So here we go. We are told that segment JK is tangent to the circle. Again, just to remind you, this we're going to do outside times the whole thing, times the entire segment. Okay, so let's take a look here. We're looking for x. So the first one, JK, the outside and the whole thing are both 12, right? So we have 12 squared equals, let's see, the outside is x, and the whole thing is going to be x plus 7. All right, so this is going to be a little bit annoying. This time we are going to distribute. So we have 144 equals x squared plus 7x. Okay, so what we have here, we have a quadratic equation, which is we haven't solved in geometry very much. It's been a little while, but that's okay. We can solve this. If you remember, the first thing you want to do for any quadratic equation, you want to set everything equal to 0. So we're going to move the 144 over, have everything equal to 0. So we end up with x squared plus 7x minus 144 equals 0. Okay. If you remember, there's lots of ways to solve quadratic equations. You could use factoring. You could use completing the square. You could do quadratic formula. Lots of different things. I am going to use factoring because that's just the method that I like the best. So I'm going to break this into two binomials equal 0. So I'm going to have x there, because my x squared coefficient is 1. Now remember, for this back half here, I need numbers that will multiply to equal 144, well, equal negative 144, and add to equal 7. Since that's a negative, that basically means that they are going to subtract to equal 7. Okay? So let's just start listing factors of 144. Well, we've got 1 and 144. Do those subtract to equal 7? No. 2 and 72 does not subtract to equal 7. 3 and 48 does not subtract equal 7. 4, yep, 4 works. 4 and, what is that? 4 times 36 does not subtract equal 7. We're getting closer. 5 doesn't go into 144 because it ends in a 4. 6, and it's divisible by 2 and 3, so it'll be divisible by 6. Let's see, that'll be 6 times 24. 24 does not subtract equal 7. Let's see, 7 doesn't go into 144. 8 will, because 4 went in with an even number, so 8, and that'll be 18. Getting closer, that subtracts to equal 10. Let's see, 9 and 16, and those will subtract to equal 7. So I have 9 and 16. One of these has to be positive, one of them has to be negative, because we have a negative right there. That's why we're subtracting the numbers. If this was a plus 144, we'd be adding the numbers. Okay, so let's see, we want to subtract it. We have positive 7, which means the 16 gets the positive, gets the plus, and the 9 gets the negative. So now I have this broken up into my factors, and so what this means is that either x minus 9 equals 0, or x plus 16 equals 0. So we're going to solve, why is it not there? We're going to solve both of these. Well, if x minus 9 equals 0, then very simply x must equal positive 9, right? Add 9 to both sides. And over here on the x plus 16 equals 0, then x is going to equal negative 16, because we subtract 16. So x is either 9 or negative 16. Now, both of those numbers work for the math, for the numbers, right? However, in terms of the situation, do both of those numbers work? Well, no, because in the situation, x is length. And length always has to be a positive number. And so my answer is x equals 9. All right, so x equals 9. Always check the question. If the question had been asking for how long is segment KM, well, segment KM is 9 plus 7. So if I was looking for it, the length of KM is 9 plus 7, which equals 16. All right. Okay. And that is segments of secants and tangents. The important thing to remember is this right here. It's going to be the outside times the whole thing. Whether you have tangents or if it's just secants, it's still outside times the whole thing. We want the outside piece times the whole thing. All right? Hopefully you found that useful, and I will see you in the next video.